Hi, I'm David Manset from EGI France. I'm the Service Area Coordinator of the European FP7 DECIDE project. Today I'm presenting the European FP7 funded DECIDE project, which stands for Diagnostic Enhancement of Confidence by an International Distributed Environment. DECIDE is a 2-year funded project which aims to provide neuroscientific and medical communities with a dedicated grid infrastructure where they can access securely and easily diagnostic tools and new research tools in dementia and other brain diseases. In DECIDE, we have a multidisciplinary consortium with 13 European institutions represented that are specialized in 3 major areas. There are grid experts in charge of deploying the infrastructure. There are application developers in charge of addressing the requirements of our end users. And then there are users, the neuroscientists, as well as clinical researchers from involved hospitals. In our project, 3 major communities are represented. There is the European Alzheimer's Disease Consortium, EADC, the DIMI Consortium for Molecular Imaging, as well as the Alzheimer's Europe Association. DECIDE intends to develop a production quality infrastructure that leverages on the GÉANT and NREN Internet Network for Education and Research, thus using high-capacity bandwidth, on top of which it is using the European Grid Initiative to process and store data. The intent, leveraging on the work done formerly in New Grid and Out-Grid European FP7 projects, is to deploy a certified infrastructure with diagnostic tools that neuroscientists and clinical researchers can use on demand. The infrastructure is ROC certified, and the quality of services is guaranteed by SLAs that are set up for the different participating sites. The actual infrastructure is made of 10 grid sites, 6 production, 4 pre-production, and exposes about 600 CPUs that are dedicated, and it can expand at any time with the resources from the life sciences grid community. In the present demonstration, we are showing an early diagnostic tool for the Alzheimer's disease that's called SPM, for Statistical Parametric Mapping, that shows the progression of the disease over time, and that is used to diagnose the change from mild cognitive impairment to Alzheimer's disease. That's a marker that highlights typical spatial patterns in the brain that you can see in yellow areas in these slices. So it allows measuring the disease evolution while diagnosing the disease stage, which is pretty convenient for early diagnostic and in particular for selecting an adapted treatment and care for the patient. The specificities of this marker is that it requires a lot of healthy patients' data, so to compare with the actual patient that we want to diagnose. The more data we get, the more accurate we are. However, this healthy patient data is very rare because it requires exposing patients to radioactive material. And there are very strong ethical regulations at both national and regional levels that do prevent from obtaining such data. So the grid for us is used as a federated database where all clinical centers can share their healthy patient data. So the grid allows sharing without moving nor copying data and is used as a single virtual repository. And the grid, in addition to that, provides users with computational power to access, process, and store diagnostic results. Each time that such a pipeline, such a marker is executed, it requires reprocessing the normal controls, the patient healthy data, to establish the diagnostic. And it is expected to be run 5 to 10 times per patient per year. In this diagram, we have a very simplified representation of what the SPM does. In the first phase, it normalizes spatially the images, so to allow their comparison. In the second stage, it checks the patient against normal parameters distribution. And then from this, it infers the data to highlight regions of hypocaptations, regions in the brain where the glucose, the tracer, is highlighting problems. And from this, we can visually find a pattern which is indicative of the disease evolution. So this is what the DECIDE infrastructure is about, providing a production quality environment for exposing diagnostic tools to users, and it's collaborating with NuGrid, which is the environment for developing and testing new markers, which eventually will be made available through the DECIDE Gateway portal. In this demonstration, we show the portal. This is the DECIDE web portal where the applications are made available, and in particular the SPM application. From here, I can access the applications and I can run the SPM. So I'm going to take my patient data to compare against the data that's in the system. So I'm going to upload an MR scan, a scan of my patient. And I'm submitting this to the grid. This is going to take about 5-7 minutes to process. Once the application has completed its processing, I receive by email the report, and this is the report output. That's a PDF file with a graphical representation of the areas where there is hypocaptations measured, and here we can pretty well see the pattern of the Alzheimer's disease and its progression over the brain.